Okay, well now let's see if we can actually find parts of a circle just knowing a few bits of information. So here's the question. Let's find the center and radius of a circle that has a diameter with endpoints 1, 11 and 7, 3 in the coordinate plane. What's the very first thing I would do? I would sketch a little picture. And by the way, I don't think it's that important that it's so accurate, but it's more for us to get a sense of where we are in this question. So let me just try to sketch a little picture, just for fun. So I see that it has a diameter with endpoints 1, 11. So I go over 1, and I go up 11. Let's just pretend that 11 is like way up here. And the other point is 7, so that's going to be around here maybe, up 3. So maybe here. So maybe this is 7, and this is 3. And again, I don't care about accuracy. I just want to get a sort of a sense of this. And so this straight line represents the diameter of a circle. So we know what that means. It means that the circle must somehow sort of go right around it. And so there's my artist rendition. So we're asked to find the center. Well, we know where the center is. The center is right there in the middle. In fact, this now allows me to gain my first piece of insight, which is if I want to find the center of the circle where I know that these endpoints represent the ends of diameter, then if I find the midpoint, I know the midpoint will actually give me the center of the circle. Well, this is great. Well, I know how to find the midpoint given 2 points, because what do? All I do is basically average the x and average the y's. Here's the midpoint formula if you want to be reminded of it in detail. It's x1 plus x2 divided by 2, y1 plus y2 divided by 2. But the thing to really remember in my mind is that I'm just averaging the x's, averaging the y's, add up and divide by 2. So let's do that right now. So if I average the x's, I take 1 plus 7, that's 8. I take half of that and get 4. So that means that the midpoint must right be here at 4. And if I take 11 and 3 and add them up, I get 14, and if I divide that by 2, I get 7, and so this point right here must be 7. And so I see that the coordinates of this point are 4, 7, and they must represent my center. So the center will be the midpoint of this diameter, which we just computed to be 4, 7. Isn't this neat? So this is great. And now how am I going to find the radius? Well, the radius is actually going to be 1/2 the length of the diameter. So I could use the distance formula, which is just the square root of the differences in the x's plus the square root of the differences of the x's squared plus the differences of the y squared. And we can actually figure out the distance. And so what would it be here? So what's the differences in the x's? The differences here would be 7 minus 1, which is 6. So I see this is 6 right here. And what's this length right here? Well, 11 minus 3 is 8. And you can see a little right triangle here. We could use Pythagorean theorem, which is the same thing as this formula. And so I see that I have 6 squared plus 8 squared. And I want to then take the square root of that. And I see that 6 squared plus 8 squared is 100. So the square root of that is going to be 10. Those of you, by the way, in the know might recognize this right triangle as a 3, 4, 5 right triangle where every side has been multiplied by 2. So 3 times 2 is 6, 4 times 2 is 8, and 5 times 2 is 10. So a sneaky way of doing that is noticing this is a very special right triangle. It's a 6, 8, 10 right triangle. Anyway, the diameter is 10. Does that mean the answer is 10? Absolutely not. The question, remember, was find the radius. That's going to be this half distance, which is going to be 5. So the radius is 5. The conic sections, whether it's the circle, the ellipse, the parabola, or the hyperbola, are beautiful objects. They each exhibit a lot of symmetry, and they each possess a lot of structure. And the more structure we see, in fact, the better we understand these beautiful shapes. Anyway, enjoy thinking about the conic sections. They're really quite spectacular. I'll see you soon.